Hello, and a warm welcome to our presentation with the title Ethernet-APL and OPC UA, Full Throttle from Instrument to Cloud. Before we start with our presentation, let us have a short introduction of ourselves. My name is Dr. Jörg Hähniche. I'm with Endress+Hauser Digital Solutions as Innovation Director, responsible for the innovation within Endress+Hauser Digital Solutions. In parallel to them, also Chairman of the Ethernet-APL Steering Committee.
I am Andreas Hennecke. I'm Marketing Manager at Pepperl+Fuchs for everything digital communications infrastructure in process industries, and I have a passion for Ethernet-APL. We would like to introduce to you the features and benefits of Ethernet-APL. So when we're talking about a process plant, we're looking at tens of thousands of signals in devices measuring pressure and temperature, or valves opening and closing. And the digital transformation to the process plant has not taken place in the field yet. For this, we would like to have direct access to diagnostics and configuration. We would like to be barrier-free from the edge to the cloud with the same protocol and communications technologies used throughout the plant, thus unlocking the potential of the field. This will be made available with Ethernet-APL, because today, when you utilize OPC UA, you get down to the controller level, but not beyond, because this is as far as Ethernet technologies reach. The reason for this are the specific requirements from the field of process industries, such as the ruggedized technology that is required, high temperature ranges, long cable distances, and importantly also many plants deploy explosion protection technologies. Thus, technologies such as 4 to 20 milliamp signals have prevailed because of their robustness and their ease in application. Ethernet-APL will change this. Based on similar technologies used today in the field, it provides a direct path for Ethernet from the management level and the cloud down to the field.
Now with Ethernet-APL, we can establish one channel for control level integration, and the second channel could be used by OPC UA to provide additional information from the feed device to the cloud. Important for that is that we have standardized information, and here PA-DIM, a standardized information model for process automation, helps.
And you see that there's a lot more involved than just Ethernet communications. The PA-DIM model, for example, takes place on a different layer of communications. But let's get back to Ethernet. When we all think of Ethernet today in our homes and our offices, we're thinking of Ethernet as something like this. The RJ45 connector that you plug into the wall outlet with your laptop, and you know it's always going to work. Now, this type of connector would look real jagged after a couple of months of vibrations out in the field. And those manufacturers providing this equipment today, because it does provide some benefit to the larger and more complicated field instrumentation, can attest to that. What our technicians are looking for in the field is a two-wire cable. This is sturdy and ruggedized for this operation and for easy installation. This is something that our installations people and technical teams are very familiar with. And this is what Ethernet-APL actually brings. It provides sturdy, ruggedized communication that includes power on a two-wire cable. It has integrated explosion protection with intrinsic safety. It provides cable distances of up to 1,000 meters. And as a side benefit, actually, it provides 10 megabits per second speed of communication. Now, you may say 10 megabits, that's not much. I have a gigabit in my home. But consider that each of these instruments is only sending one value. And there's lots of them out there. The latest technology that we have in digital communication in the field communicates 300 times slower than 10 megabits. So this is a very, very large improvement over the technology available in the field today. Now we're all looking to standardize this.
Yeah, such a new technology cannot be developed and introduced without appropriate support. 12 industry partners and the 4 leading standardization development organizations support this development and activities. And we are happy that even OPC Foundation decided to join that project. It shows the importance of this new technology for every standardization organization, because there is a huge potential, as Andreas already mentioned. I'm also happy to see that this 12 industry partner covers each area of an automation solution, starting with the DCS system to system components to field devices like sensors and actuators. With this cooperation, the most important prerequisites are given that Ethernet-APL becomes reality. Now let us have a deeper look in the outcomes of this Ethernet-APL project. Ethernet-APL is designed to incorporate intrinsic safety, but works for non-intrinsic safety applications as well. As Andreas showed, it is really a 2-wire solution, which allows the power supply and communication via this 2-wire. It is protocol independent. Since we used standard Ethernet interfaces, each protocol, industrial protocol, as you see here, or any other application can run over Ethernet-APL. Also important is with this 2-wire that we have an easy and robust connection of the device, which is appropriate for the process automation industry. And even with Ethernet itself, it's a state-of-the-art technology which we are using. And that ensures a future-proven solution. Even the 10 megabit bandwidth gives us really a huge potential for additional use cases to be fulfilled or applications. In order to have this outcome done, several work packages and milestones have to be passed. One important part are the standards, because since the beginning, it was clear that we have to develop an open, standardized solution and not industry proprietary solution, which can only be used for specific part and is not open for everyone. So the standard gives us the possibility to be open to develop products out of them. New standards have been developed, like the IEEE 802.3CG standard, which was released in end of 2019, published in 2020. And the name is even 10 base T1L. That's the core of Ethernet-APL. In addition to that, the explosion protection mechanism had to be defined. Here we used an approach which is already known in process industry called FISCO. And the new solution has a name 2-wire intrinsic safe Ethernet, which is as a technical specification added in the IEC 60079-47. Other standards will come, like the port profile specification will also be standardized in IEC soon. It exists today now as a specification, will be published by the standardization organizations. In addition to that, the further specifications and guidelines have been developed in order to ensure the interoperability between the devices and makes the installation of Ethernet-APL and the network design easy for the user. I'm really glad and proud that we are able to launch yesterday officially this new technology to the market. So that means everything is now available to start product development. We see also, or have seen in demonstrations, already existing products, which can now be used in real projects. So, and I hope that this will be happen in the near future, that we have a lot of projects where Ethernet-APL is used. To summarize the standards, and even as I said, the standards gives the possibility to have really for everybody access to that information for their own development. It's even the new standard IEEE 802.3 CG, which describes this 10-based T1L solution. Then the IC technical specification for this two-wise concept. We reuse existing cable specifications like this IC 61158.2 type A cable. And soon we will have an extension of this IC 61148.2 standard by the port profiles. This standards ensures that we have protocol independency, that it's robust, and we can reuse existing cable, and we ensure the interoperability between the devices, as well as easiness of installation and commissioning of an Ethernet-APL network. The process industry is facing a radical change in terms of digitalization. So more information from the field are required to increase the efficiency of production, but also maintenance processes, together with an increase of quality. On the other hand, it is expected to decrease the total costs of ownership by this digitalization. So OPC UA as a second channel gives the opportunity to have easy access to all this information in the device on a standard way. So that reduces the risks, makes it simpler to get access to that data, and that's what is required if you would like to do digitalization. Why we can do that? It's because now we have enough bandwidth available to run in parallel different protocols. So in that way, we can even support the real-time control for process. We can provide asset management applications on the same network, as well as process monitoring and optimization. So that means we have one network technology where all these applications protocols can run in parallel. The benefit for us is to give even more flexibility and scalability. We can ensure the availability by redundancy concepts. And sure, security is also a topic. And with such a solution, a secure communication can be ensured.
So to summarize all this, one of the important aspects is that Ethernet, as opposed to our existing communications that are pretty much proprietary to the field of process plants, provides this type of parallel communication. It provides it on two wires. Now, having all of this will allow users to optimize their assets by accessing additional process variables or gaining higher accuracy through a digital transmission. This will also help improve quality and reduce waste. Ethernet also has the benefit of being extremely scalable. This means that skids that are already fitted with Ethernet can easily be integrated into larger plant concepts. This also means upscaling of smaller plants and reactors to full-scale production. And one of the important aspects of Ethernet as the carrying medium of data to the field of the process plants is that it is future-proof. Ethernet will always adapt and adopt to the latest standards as they develop today, for example, for safety and/or security. We will also see system integration improve. Consider that each and every instrument will automatically connect to the engineering station because Ethernet allows two-way communication and network communication. And with diagnostics and troubleshooting, the technicians have access to the data that is stored in the engineering station and at the same time to the manual that is stored in the instrument or the certification documentation. So with advanced techniques, Ethernet-APL enables these techniques to be deployed in the field and providing information at the right time and where it is needed. Finally, installation technologies are a lot easier to harness with a physical layer that a lot of technicians are familiar with today, and that is our simple two-wire cable. So all in all, we're getting a barrier-free communication that reaches for OPC UA from the cloud all the way down to the edge, full throttle. So what would be your next steps to deploy Ethernet-APL? There are a couple of options. If you are a vendor, connect with the experts of Ethernet-APL to learn how to get involved. If you're a plant operator, connect with the subject matter experts to figure out how to develop a plant, or possibly as a first step, take a virtual tour of our Ethernet-APL multi-vendor demonstrator. Finally, we would like to invite you to our October event. On October 5 and 6, we will be conducting educational series and have longer discussions than what we have available today. Thank you for listening.
Thank you.
We also invite you to look at the streams and the recordings of Exhibitor Channel 3, where you have had the opportunity to review the technical details and presentations from the subject matter experts that developed Ethernet-APL.
Hello, the OPC Foundation is a worldwide non-profit organization with more than 815 members. Together we share one vision. We want to seamless move information, standardized information from the field up into the IT and cloud and back in an end-to-end secured way. The OPC Foundation supports the ACHEMA Pulse in 2021. And we have been looking for a real-world demo. And we found this here at the company SAMSON in Frankfurt, Germany. We are showing here all kinds of technologies, including Ethernet-APL, OPC UA, also information models like PA-DIM. The OPC Foundation joined the Ethernet-APL initiative last year because this is a perfect enabler for us, opening the way scaling from edge down to the field. And so OPC UA can grow into the field with our so-called field level communications initiative. The OPC UA FX extension are exactly to enable OPC UA from the field, interacting with each other, but also moving the data up in a standardized way to the cloud. Ethernet-APL technology is available now. Standards have been completed and products are entering the market. And this is what we see here at this demonstrator, where I'm really proud that we can show a multi-vendor demo, including not only SAMSON as a host here, but also components from Endress+Hauser, Pepperl+Fuchs, and we are collecting information and moving them via OPC UA into the Microsoft Azure dashboard. So I'd like to thank Guido König from company Samsung, but also ask him to give us more details here. Guido, thank you that we can be a guest here. Can you explain us more information about this demo?
Of course. Thank you, Stefan. And as well, a warm welcome to this real process application demonstrator. In this case, a level control loop, combining different instrumentation from Endress+Hauser for flow measurement, as well as pressure transmitters and level meters from Pepperl+Fuchs. Pepperl+Fuchs gives as well the infrastructure for this Ethernet advanced physical layer-based demonstrator. Ethernet to the field, to all the field instrumentation, is the high-speed connectivity available in this demonstrator, available in products to perform not only the communication, but as well to continue established standards, for example, two-wire technology to power and to communicate over the same line, as well allowing to be installed in hazardous areas for process applications, as well as performing long distances. Communication at a glance. We see the capability to combine different protocols for different usage. To do the control at its best, or as Stefan mentioned, to run OPC UA for transparent data exchange based on standardized information models like PA-DIM. Communication, the base within this demonstrator for new services regarding monitoring, regarding diagnostics, as well as predictive analytics, to maximize the plant performance and efficiency, or to be honest, in this case, to perform and to run efficiently within this demonstrator. Utilizing information with new services for maximizing performance and efficiency.
Thank you so much, Guido, for the explanation. And I'd like to invite you, if you're an OPC Foundation member and you'd like to participate in the next year demonstration for the ACHEMA 2022, please contact us to be part of the next year multi-vendor demonstration. We want to extend this demo and include many more components and services, collecting data, moving them to different cloud dashboards from different vendors. So please join the future.
Endress+Hauser sees OPC UA as the Ethernet communication of the future, especially regarding the second channel for monitoring and digital services. Together with the information model PA-DIM, it offers the first time an open standard not only to transport data, but also to provide automatic interpretable information. And that's the base for our customers and plant operators to advance digitalization. Open approaches like the NOAA concept of the Namur, the connectivity framework from the Open Process Automation Forum can now be realized without any additional cost for infrastructure and engineering. At the same time, risk due to interference in the core process is avoided and the engineering cost in total is lowered. Advancings like OPC UA PA-DIM in connection with PA-DIM profiles offer a lean way to provide this information even from simple devices. Therefore, Endress+Hauser is since many years member of the OPC Foundation and contributes in these activities to enable our customers for a full-scale use of these advanced technologies and the added value provided from digitalization.
Ethernet-APL in combination with OPC UA is a real enabler for connecting the field level to upper level asset management systems. We use those systems, like for example the SAMSON valve management platform, to ensure that our valves are working properly, or in case of a failure, to schedule maintenance activities already at an early stage. With this regard, we expect OPC UA to become the main standard for secure data transmission over a second channel according to NAMUR open architecture.
With APL, Advanced Physical Layer, the Ethernet standard family got extended recently. This will unlock all the advantages we have seen so far at classic 4-wire devices for the group of 2-wire devices, such as level or vortex flow. And it will be real 2-wire, so includes power supply on the same twisted pair cables as the communication runs. And we would not mention it during ACHEMA when it would not have an option for intrinsic safety. Here we see ABB's laser level transmitter LRT100 with Ethernet-APL connected to a control panel CP600 series. And that's the right time to mention a protocol with great potential in machine-to-machine communication, OPC UA. Classic field buses such as Hard or Profibus and also its new Ethernet-based variants, Hard IP and Profinet, are optimized for use in machine-to-machine communication, as this is the core of automation. But when it comes to IT integration and cloud connectivity, it is getting hard to configure specific gateways, map data between OT and IT world, or access diagnostic information. OPC UA was designed for this purpose. It gets growing acceptance in both the IT and the OT world. As semantic protocol, it includes all of the needed information to interpret the data correctly, without the need of a device driver. PA-DIM, the field device information model for maintenance and optimization, standardized for the process industry, gives structured and unified access to most used device variables, parameters, device health, and asset information. This does not only make device commissioning easy, it also ensures a smooth device exchange. With the same protocol, local controllers can access the device, but also configuration tools, operator panels, and even services running in cloud or edge. No gateways, no data mapping. Here, the panel cyclically reads process value, unit, and range from the level transmitter via OPC UA. Besides the semantics and structured data access, it's the integrated secure communication what makes OPC UA so IT-friendly. What is state-of-the-art in standard Ethernet communications, encrypted and secure traffic, is usually not supported by pure industrial protocols. OPC UA overcomes this burden and has an integral cybersecurity concept, what makes it preferred for device-to-cloud communication. With that product, ABB has proven that even field devices with lightweight processing capabilities, limited memory footprint, and ultra-low power design can run an OPC UA stack with sufficient performance, even for using it in real-time control loops.
Open standards are a key feature of the DNA of backup automation. Consequently, OPC UA is one of the most important standards for us. Therefore, we've been one of the first early adapters of OPC UA in 2007. Our customers used OPC UA in different vertical markets. We've seen success stories in discrete market like wind energy, water water management, or in process industries like oil and gas, chemical and petrochemical plants. And especially development of APL in conjunction with OPC UA seems to be one of the next big things for process controls. Therefore, we're looking forward for future success stories and the development in the market.
Good day, everyone, and thank you for taking some time to learn about the effect IoT convergence has on industrial control system migration. I'm Michael Clark of the OPC Foundation North America. My experience spans over 30 years in the process automation industry with particular expertise in instrumentation, industrial data communications, and field bus systems. I am a principal author of Part 6.4 of the Open Process Automation Standard, and more recently, I joined the OPC Foundation to help the North American market understand and more fully embrace OPC technologies. I appreciate it when presenters take the time to clearly define what problem is being solved in their presentations. So to do this today, allow me to share, first of all, a few process industry observations. First of all, the industry is very conservative. Secondly, a lot of these facilities are built to last forever. Now, I say that a little bit tongue in cheek, but it's not as crazy as it sounds. I mean, I was working not that long ago at a plant in the northeastern United States, which still ran on manual and pneumatic controllers. They had been installed before the Second World War, so forgive me if I say that it seems like these plants are built to last forever. I think you see my point. Next observation is that change for the sake of change is really never allowed. In fact, there's very little room for trial and error. The general mantra in these process facilities is that if it ain't broke, don't fix it. Lastly, is there perhaps some hesitancy to spend hugely on a migration effort now for fear of missing out on a better solution afterwards? Or worse yet, spending now on a costly migration with no guarantee from your automation vendor that you won't be right back at square one only 10 years from now. Maybe to give a little bit of context, here's a side note, just so we can understand and aren't trivializing this real anxiety about system migration. A benchmark cost to migrate a large refining facility is north of $3 billion, sometimes even double that amount. And that doesn't even take into consideration lost production revenues. So I thought it would be important for us to understand that benchmark. So I said at the beginning of the last slide that I appreciate it when presenters identify the problem that they're trying to solve, and I can safely say that we haven't identified that problem yet. So let's see if we can get a little closer to a problem statement by asking a few more questions. Not to pick on any particular discipline, but as an example, let's ask a question that will help us narrow down the problem. Why do we need system integrators? Well, to be clear, the answer is in their job title. They exist to integrate systems, but why? Wouldn't it be nicer if the automation systems integrated themselves? I think that would be nice. Here's the root of the problem. Industrial control systems don't exchange data openly, securely, or interoperably. That's the real problem. Over the course of my career, I've had the opportunity to listen to a lot of end users lament the fact that they feel a little bit trapped due to vendor lock-in. They often wonder if there's any escaping that situation. I can say there is hope because many of the vendors are now coming to the realization that the process industry is moving toward open, non-proprietary interoperable systems, making the current installed base a little bit of a thing of the past. I think it's safe to say that it's game over. It's a favorite thing of mine to use metaphors in my presentation. I've been to my share of orchestral performances in my life, and without exception, every member of the orchestra tunes to a single standard. I mean, there's one leader, a peer among them that helps them. The concert master violinist sets a standard openly for all to hear, and then the performers tune to that standard note. We in the process industry can benefit from standardizing on an open for all to hear methodology that puts us in pitch perfect key. Since our presentation today is talking about the effect that IoT has on control system migration, let's look at a very simplified sketch of our current state. Looking closely at the IT connectivity portion of our process facilities, we can and sometimes do use gateways to bring either monitor only or asset management or even predictive maintenance data to the enterprise. Not every plant does this, but for those that have done so, there is a component of customization or integration effort that can be costly and time-consuming. Turning to the field connectivity side, there are truly no surprises here. We traditionally use analog instrumentation as well as serial comms and HART-enabled devices. A bit of a side note on HART devices. I remember a statistic shared by Ron Helson when he was still with the HART Communication Foundation. In fact, they even published this on their own website at one point, that over 80% of the HART installed base were not used to provide anything more than the basic 4 to 20 milliamp signal. In other words, not many of these users felt the need to access the HART channel or the HART diagnostics. Continuing with the field connectivity side, you notice that we've listed field buses here. There are a handful of process facilities in North America that have bus technology, Foundation and Profi. But the more prolific use of these technologies is in burgeoning markets like Asia, the Middle East, and parts of Europe. So going back to this sketch now, let's generally agree then that this is the baseline that is largely representative of our current state. It's possible that some of us are indeed more advanced in our deployments, but again, let's agree that this is the current state. Quite some time ago, Namur devised a standardized system of alerts. They called it NE107. One problem that we ran into with this was that the existing industrial control systems couldn't easily pass this data from field to controller to asset management system, at least not without some heavy lifting and significant cost to the owner. Since these diagnostics remain for the most part stranded, Namur devised a new plan, mainly because the process industry didn't want to rip and replace their control systems to upgrade to more sophisticated hardware. You recall me saying earlier that it costs a significant amount of money to do a migration. Namur deployed a workaround, a second channel in other words, completely abstracted from the core process control system. They called it Namur Open Architecture, or NOAA. So let's go back to our original simplified sketch. We see that without changing any existing field connectivity, Namur created NOAA in a way that accesses the stranded diagnostics found within some incredibly intelligent field devices already installed in many of our plants today. The red outline shows the area of focus where an OPC UA and gateways can leverage configuration, and diagnostic data waiting to be harvested. By the way, even though NOAA has been around for some time, it's still surprising to me how so many in the process industry know so little about it. What's more is that it's difficult to motivate some of these folks to action, even though this strategy leaves the core control system untouched. In both of the upcoming two slides, we're going to be talking about standardizing data. This particular slide shows changes that we can make on two fronts with respect to industrial control system migration. First of all, with respect to IT connectivity, we can deploy standardized data models that provide semantic structure to the confluence of both control and diagnostic data. You can see here a small list of partner organizations that have taken time and effort to collaborate across industry sectors to develop standardized information models. Listed here, we see DEXB, MDIS, PA-DIM, and let's not overlook VDMA. They are very prolific with over 20 companion specs alone. On the second front, the field connectivity application, we can leverage the good work of Ethernet-APL, which provides a standardized and industry-supported means of bringing high-speed data transport capabilities to the plant network. Now, devices can not only utilize a free way of data throughput, but also a means whereby we can power instruments on the same wire pair. So as I mentioned in the previous slide, we are discussing standardized data in both of these slides. However, this slide takes us to a whole new level. I'm sure many of you have heard Peter Lutz, director of the FLC initiative, speak about the OPC UA FX specifications that the FLC working groups are developing. By the way, if you haven't heard about this initiative, I urge you to please check it out. Anyway, Peter and his colleagues have developed controller to controller, or as we like to say, C to C, field exchange or FX standards, and are now focusing on controller to device, or C to D, and device to device, D to D developments. Notice how field connectivity advocates the use of Ethernet-APL here, which facilitates the FX information model propagation from all domains, C to C, C to D, and even D to D. It's so perfect. Speaking of open architectures, there are great strides being made in the OPA forum to create just that, an open process control architecture, where we can apply technology advancements that take us well into the 21st century. So rather than restrict ourselves to the layout of the previous sketches, let's zoom out a little bit and look at a more holistically ideal scenario. Here we see openly integrated IT and OT networks, entirely interoperable, and let's not forget secure. Sharing data across all automation system domains and the external world. Will we still need system integrators? I say yes, but not in their current roles. Their roles will be so different and easier to perform since they will no longer need to do data mapping, alarm masking, gateway configuration. I think you get the picture. I apologize that this summary graphic is a bit of an eye chart. However, as stated in the presentation title, we are exploring the impact that IoT has on industrial control system migration. Notice each of the steps we can take from our current state to the ideal state. I'm happy to say that we're not that far away from such an achievement. I don't think it's lost on you that OPC UA serves as the orchestration between each of the process automation domains we've addressed today. That's no accident. In fact, OPC UA has been at the forefront of developing a neutral environment in which these ideas can incubate. You could say that the OPC Foundation is the United Nations for industrial automation, in the noblest sense of the meaning. This neutral environment, this place to safely collaborate on open standards, is turning out to be the kind of orchestra in which the industrial automation world wants to play. So getting back to our problem statement, we said at the beginning of the presentation that process control systems don't exchange data openly, securely, or interoperably. Did we find a solution to this problem? I think we did. But just like learning to play an instrument, it's going to take practice, time to rehearse. The plan is there, the work is expertly composed, and OPC UA is poised to be the global standard orchestra leader. They'll keep us all on the same page, on key, on tempo, as one global standard, open, secure, and interoperable. I sincerely believe that the process automation industry has a very bright future. Our collective hesitancy of the past need not be our future case. In fact, I'm pleased to have been part of the end user community who have been actively defining use cases to assure a proper turnout of the specifications going forward. There is good reason to be optimistic. Having said that, let's conclude today's presentation by inviting you to forward any questions you may have to my email address listed here. Thank you for your time and attention. I hope I've given you your own reasons to be optimistic. Bye for now.
Thank you for having me here. It's a real pleasure to be here. Yeah, so my name is Joao Pinheiro. I'm a senior technical team lead at Equinor, and I'm going to talk about the strategies for data-driven digital transformation in the plant. Maybe we can start a little bit with the company. So we are Equinor. We are a broad energy company with 21,000 colleagues. We are committed to turning the natural resources into energy for people and progress for society in more than 30 countries worldwide. We are dedicated to safety, equality, and sustainability. As the largest operator in Norway, a leading international offshore operator, and a growing force in renewables, we are shaping the future of energy. Equinor's strategy is based on 3 pillars: always safe, high value, low carbon. To reach our ambition goals, we need to stay in the forefront of digitalization, implementing and creating value from digital tools. So digitalization is here to transform the way we work and enable us and support in our strategy and goals. So we need to use data to improve safety, to reduce our development and operation costs, increase recovery and discovery, and reduce the greenhouse emissions. Our digital roadmap is centered around 6 programs, cutting across the company and 3 key enablers: developing digital capabilities and leadership, utilizing the external ecosystem, and developing our unified data platform. For example, on this 3rd objective, we recently built a cloud-based data platform called Omnia. Here, relevant data is made available, irrespective of its source or its point of creation in the value chain. The idea behind this platform is to move from silos of data and across our value chain to one common platform that orchestrates all our data across the value chain. One of the areas and programs in our digital roadmap is data-driven operations. This is about using data to maximize asset value through production, optimization, and maintenance improvements. So let's start with the first one: data. Data, you simply need data to be available if you aim to run your business based on data. So the challenge in Equinor and many other industrial companies is that data is tightly coupled to the applications, where each application has their own data interface, own data model, own data access regime, etc. If you look at the second one, the context. Data without any context is quite useless. You need context to ensure that humans and machines understand what the data means in order to be able to use it. So when you have data and context, then you have information which can be used for analysis and visualization. So making data or information available to humans and machines for analytics visualization, it's critical. So we should use it. Business decisions. The final step is to make decisions faster and better based on insights derived from contextualized data and or analyzed data. So OPC UA is a connectivity framework for industrial automation data that is really supporting us and helping us to contextualize data available from our industrial automation and control systems. So here we have a drawing which shows us the heterogeneous versus the information world, so OT and IT. So we can start with the physical equipment on the bottom here. So we have the physical equipment, which has a real-time embedded computer controller, and this is sending out information to core process control, so SAS, a drilling control system, which has its own HMI. And then this data is tunneled through an OT-IT gateway, which is then sent out to process historians, which are IMSs, and this is then sent out to an historian cloud exporter, goes through a broker, and then it's stored in an Omnia data lake. And then also we have the data available on a time series database. So if we have a data consumer in Equinor that requests to have access to a certain amount of data in Omnia, they send out a ticket to the Omnia team. Omnia team prepares an API, and then it's available through this Omnia API to our suppliers, to our data consumers, or whoever wants to have access to this data. Here we have two examples of two sensors which are sending us data, but this is data without information, without context. So if you look at the two tags, you see that these two tags, these 27TT3011 and 27TT3061, they are giving us a value and the quality is good. Okay, so we have value, quality, and timestamp. However, we don't know exactly what this sensor is measuring. So it's measuring what? Is it the valve? Is it the pump? Is it the motor? Is it the outlet temperature, inlet temperature? Is it upstream, downstream? So in order to answer this, we need to have context on this data. So the most powerful game changer to obtain context is OPC UA. So it has an ability to turn data into information, data in context, with the OPC UA information model framework. Its ability is to standardize on information across vendors and products using OPC UA component specification. And this results in interoperability. OPC UA is an open, international, industry-independent, and secure connectivity framework is supporting Equinor in making real-time contextualized data, which is information available. So this means that 2 out of the 4 pillars to become data-driven are already established. But to do this and scale in speed, we need interoperability. So it is important that we also have our vendors implementing OPC UA, so we can lift out the data from the bottom level until our Omnia in a much easier and much faster way. So our plants, they are heterogeneous, meaning that we have many different vendors delivering software and hardware on the same plant and across plants. If each vendor is delivering the same type of data in different vendor and system-specific interfaces with vendor and system-specific information models and semantics, then humans or our engineers need to spend a lot of time interpreting this and mapping and transforming this. So interoperability means that we have similar information organized and defined in a standard way, regardless of what the vendor and the system we are talking about. So we agree on common and open formats, information models, and connectivity standards, and we need to have well-defined, understood interfaces. So an OPC UA server can look like this. It can look like with a very good structure where you have the equipment, you have the system where it belongs, you have attributes, you have a nice structure. So an address space that gives you data context information powered by an object-oriented types and instances information model. So an address space where you can browse relations, you can find the connections between objects to understand how things are connected. But it also can look like this, which is really good. You have a good structure again from one of our vendors where you have the sensor. You also know that it's an analog value and you know it's actually current for phase 1, phase 2, and phase 3. And it's very easy to transform this into our model, which is basically almost the same. Now, there are also other less good examples. For this one, for instance, when we look at the analog values that this UA server is sending to us, it's very hard to retrieve any kind of context from this analog values. We know it's 1 to 27, but what are they measuring? What is the value that you're getting from this? So we don't want suppliers making their data available like this on their OPC UA servers. We, meaning the entire industry, need to agree on standard information models for given domains and assets. This is another bad example. So for instance, when we browse a server with this kind of information, it's almost impossible to know what they're describing here. So in order to be able to transform this into something readable, we have to go through technical documents and we have to map it to something that is understandable. So we know that these first tags actually represent foam, gas, oil, and sand density levels. So OPC UA has been implemented and proved in use at scale on Johan Sverdrup. So this project started production in 2019. This field alone is massive. It produced 30% of Norway's total production. And OPC UA has been a central part of the digitalization strategy since 2015. So we have in total 19 OPC UA servers on the plant floor, aggregated into a single OTIT gateway using OPC UA aggregation architecture. So let's take a look at the architecture. So if we start with the top right corner here, this corner here, we have the OPC UA library. This OPC UA library contains the template of all the objects and types and classes that are defined for all the different equipment that we have in our system. And in here, we have the engineering database. And the engineering database means that it contains all the equipment tag names from on our database. So when we merge our library, which is a template, can be used in any project, with this database, we get a plant-specific mapper, meaning that we have, on this case, Johan Sverdrup, we have combined all the types and all the objects with the library, and then we get automatically assigned types for all these equipments. So meaning that, for example, this well, this equipment, they automatically get assigned a type. So we don't need to do any manual intervention here. It's an automatic process. So all we have to do then is assign the class, which gives out the attributes, which we then show on the upper level. So if you now go down here to the infrastructure, we have an aggregated server. So we have down here all the sensors that are sending us OPC UA data. All these sensors are then aggregated, sending out to these servers, these DIG or IACS Gateway servers. The data is now available here and then is replicated to an OTIT gateway. Then when we combine the data available down here with the plant-specific structure that we get all the types and classes here, then what we get is an information model like this. And then what we do is we send out that information model to a collector, That collector stores in the data archive, and then it makes it available all the way down here for anyone with a tablet or phone or computer. They can access to this data. So they have a visualization tool which they can access to all this data. So you see, with just this 3-step here, this one, and this one, we get all this highlighted area pre-built. That's a lot of work already done here. And then this area here is just built on this server here by assigning classes to the right equipment. Just some fun facts. Our OPC UA library, so the template, consists of 50 objects, 90 classes, and 920 attributes. So it's the same library being used in multiple assets. It's already been used in renewables as well, so it's not strictly connected to oil and gas. Our visualization consists of more than 745 pictures that are connected to this data that we have available. And our tag server has in total more than 190,000 tags, which we will upgrade soon to reach about 1 million. So there's a lot of information, a lot of models already being available on this structure. Our UA asset structure has more than 31,000 equipments. So these are the equipments that are automatically assigned the type when we do the connection between our library and the database. And they have more than 1 million items and references. So we utilize and we benefit from this community. And by open sourcing these information models, we also contribute back to the community. So you can go to this link here and you will find our library, the template library that I was showing you before. You can find it there and you can use it for your own purpose. So we believe that being open is a key to achieve adoption, and we believe in openness is the spirit of OPC UA. There are many end user benefits, but let's just highlight some. So it reduces the total cost of ownership. There's an efficient exchange of data without needing human translators in the middle. There's an increased flexibility in the overall architecture. Easy to replace, it's plug and produce components since the interface and information models are the same across vendors. OPC UA is designed for and used across industries. A supplier can use the same interface and the same information model across customers, across industries. Innovation, opportunities, data-driven operations. By utilizing the intention behind OPC UA, we get easier and cheaper access to higher quality contextualized data from our plant operations, industrial automation, and control systems. So more access to innovation due to broader communities, ecosystems, and international competence, and more competition. So companies now need to compete on business value and not making it vendor locked in. Also, the ongoing and future areas that we need to focus on now. We need to scale up the standardization of OPC UA information models. So there's a huge potential, but we need more and more vendors to start using this so we can scale up much faster and much cheaper way. Closer integration between the plant floor and applications and the service in the cloud. This means that we need to make not only the data, but also the context available from the OPC UA servers. So at this point, our information model is kind of hidden on this silo within the OTIT gateway, but we need to expose it also to Omnia. Usage of automation ML and OPC UA together. So we need to close the loop between the engineering and operations. Alignment towards international initiatives like NAMUR Open Architecture, NAMUR Model Type Package, Open Process Automation, Industrie 4.0, all of them point as OPC UA as one of the several key building blocks. And end users to have one voice towards the suppliers when it comes to OPC UA. Yes, and that ends my presentation. I hope you enjoyed it, and thank you again for this invitation, and I hope to see you soon. Bye-bye.
Welcome to the session on IT/OT convergence in the process industry. My name is Claudius Link and I am the Senior Vice President for Engineering of Manufacturing and Industrial IoT at SAP. Today I would like to outline opportunities we see by applying the frameworks and principles of OPC in your business operations, which are supported by SAP and embedded in its solution portfolio. Let me briefly reflect on the business needs. Businesses are realizing they need to optimize end-to-end business processes along their entire supply chains. Speeding up product development cycles and reducing the time from formulation to consumption, they face questions like, how can we deliver individualized products with smaller batch sizes at the cost of mass production? How can I predict and react on unforeseen changes, may it be demand or supply variations, or operational issues like unplanned machine downtimes? How can I reduce the setup and cleaning times to be able to quickly change my line setup? Those questions and challenges are on top of mind of almost every business executive while being under pressure to increase productivity, reduce cost, deliver higher quality, and ensure safety, sustainability with lowest carbon footprint and compliance of operations. To address those challenges, flexible production systems are required, which are seamlessly integrated and synchronized with the end-to-end supply chain processes. There are several dimensions which need to be considered to address those challenges, but at the core are production and logistics operations, which need to be optimized to achieve these goals. One of the levers are new levels of information to synchronize business processes and real operations. With OPC UA framework, IT and OT systems become more easily accessible at scale and become the source of significant new sets of information. This is opening endless opportunities to optimize existing processes and eventually allows you to enter into new business opportunities. The key is to bring IT and OT systems closer together. We call it the IT-OT convergence. What do we mean by that? When we talk about IT-OT convergence, this is not about IT taking over OT, nor vice versa. It is about how do I get data and information from my real-world operations available in OT systems to decision makers which are supported by IT systems. And how can I close the loop from the decision back to the operations to execute on those decisions swiftly? Synchronizing real-time event-driven data from actuators, sensors, systems with decision support and information systems sounds easier than done. With OPC technologies, you find an open framework, allowing you to exchange information across systems and platforms. With this standard communication, bidirectional, secure connectivity to equipments becomes easy and affordable. Budgets and time can be better spent to increase insight and productivity. With standardized communication, implementations become scalable and solutions can be deployed globally. The standardization of communication and security protocol is one critical part of the framework. It also provides a number of specifications, a set of information models addressing a wide range of application domains, ranging from field bus, asset administration shell, to enterprise information models. With those initiatives, the interoperability will become easier and both systems engineering and automation of processes becomes faster. The orchestration and monitoring of systems is less custom and more affordable. Now, if we bring IT and OT systems closer together, the systems of operations can be connected with the end-to-end business processes in the system of information, from ideation and formulation to consumption. So, with the SAP system, we bring industry domain and business knowledge into the mix. With those new levels of information, you will be able to optimize the entire value chain. Let me give you a couple of examples. Speeding up product and process development cycles. Imagine, production processes can be adjusted and quickly reconfigured. Smaller batch sizes will be possible due to lower setup cost with more flexible production processes. Decreased cycle times ensures batch runs are more effective and predictable. Quickly responding to unforeseen changes with real-time information enables a synchronized supply chain management. A digital twin of the production process can be subscribed, and thereby alerts and events can trigger automatically rescheduling activities. Increase the productivity of the production process by getting more transparency into the production process, which drives ultimately the overall equipment effectiveness. This is done by getting insights about the process and quality of the production process. Predictive models allow businesses to reduce scrap and increase yield. Models can be trained to assess in-process quality criteria and process parameters. Preventive actions can be triggered to avoid quality issues and downtimes. Smart sensing of both the production process and the work product does ultimately connect the physical product flow to the supply chain processes. This does not only simplify logistics, but it ensures full traceability of the process, supporting regulatory requirements. Finally, the utilization of high-cost operating assets can be maximized while reducing service and maintenance cost. Combining OT data and maintenance information is generating insights for maintenance professionals and allows to define support and maintenance strategies. Eventually, information can be shared with business partners. All of this is more easily done by standardization of communications and information models, combined with state-of-the-art, data-driven business processes. Common semantics and modeling of the physical world are critical for that. Therefore, an enterprise asset model, which is synchronized with your ERP system, serves as a cornerstone to define the business-critical information, but also the connectivity and services provided by each asset. The asset administration shell and companion specifications are the basis for common semantics and efficient onboarding. SAP Edge services are providing connectivity and distributed intelligence. An open connectivity framework supported by OPC UA client and server architecture allows you to connect to almost any asset, collecting data using the edge, pre-processing, aggregating and synchronizing data with the cloud becomes the norm. Decentral intelligence and applications on the edge to monitor, trigger and execute processes, rules, actions and events support you to detect anomalies and trigger alarms. All of those new information sets flow into an application platform for digital operations management, covering all of your mission-critical processes. The platform is hyperscaler agnostic, and big data lakes combined with machine learning and artificial intelligence deliver new levels of decision support. SAP is taking the business process transformation and standardization to its next level by unlocking the power of connected IT and OT systems. In the following short demo, we would like to give you a glimpse of what can be done.
Hello, my name is Rüdiger Fritz. I'm working as a product manager at SAP. I have also a role in the OPC Foundation supporting the board, coming from the marketing consulting board. But today I'm talking to you as SAP member, and I would like to show you the so-called EvoMix behind me. So no worries, the EvoMix is just a working title of this little demonstrator. For sure, in your process industry, in your home factory, it looks certainly much more impressive, broader, bigger, and so on. But it's all about the principle. And as you see, we have a lot of elements which you also recognize in your real-life environment. Double-seated valves, for example, tons of different sensors. We have various tanks which should represent different liquids that have to be mixed. But certainly this is all just about mock-up, and we are not really mixing real liquids. But on the other hand, it's with regard to the automation exactly as you would have in real life. So behind there is the logic controller and the complete communication between our SAP world, the IT world, and the automation runs over OPC UA. So maybe a quick demo here on the other side of my screen. You see here a classical SAP environment where we would say, for example, let's create a new production order, a new process order. And as I said, it's all about a little bit mock-up, but the principle behind that we communicate between the IT world and the automation via OPC UA is built in, and that's no mock-up. So all the architecture, the layering is like it would be in real life. It just certainly is that nobody produces with this dummy machine called EvoMix. Let's assume we want to create a new order. This is our example how to create a recipe based on red, green, and blue color, because we certainly do it just via lights, via little LED lights. But let's imagine our product that we have to produce consists of 3 recipe elements, which is based on colors here, a color picker. And let's assume we want to produce these bluish liquids. We can forget about this premix phase. It's another element of our demo. It's all about weigh and dispense, story, and so on. But it shall be here just a quick demo. Maybe as you see, I've prepared a little bit like in a good cooking show. It's the OPC Foundation ROCS order. And now I'm starting to save this production order in our IT environment, in our SAP manufacturing execution environment. And okay, this process order is created. This is certainly still in the IT world, no connection to the automation right now. But as soon as I say I want to start this order, the first thing that happens is we have built in, just for the principle, check quality management means we are really taking measurement values from the EvoMix. So we have there, for example, conductivity, temperature, density, all done with this huge flow meter over there. This is live data which comes from the automation layer, from the sensors, via OPC UA into our manufacturing environment and say, okay, this is actually the measured values. Now let's say I'm the specialist, I am fine with these values. I just confirm, yes, my order can start with this data. And now this recipe transfer happens. So via OPC UA from our manufacturing execution down to the automation, we transfer the exactly chosen value from our order. And as you see, it's starting really the mixing process, certainly just some bubbling water. But on the other hand, you can see valves open. Valves open according to the ratio. So how much green, how much blue, how much red do we have inside? Certainly this opening and closing of the valves, this is nothing that the SAP software is doing. That happens inside the logic controller. But the logic controller inherits and receives the recipe information and permanently interacts with the SAP software with regards to the confirmation information. Right? So my order is now in a few seconds done. We can now consider this communication from sensors to SAP, but also from SAP down to the automation layer and saying, please, dear automation layer, start mixing. As I said, it's just a dummy. If you follow this process, it runs about 30 seconds. You will see on my screen that we also get the order done confirmation from the automation into the SAP world. From there on, we could tell a lot of additional stories like putting the measured value, the as-is information into a blockchain, like doing the complete order management until fulfillment, so until shipment to the customer and so on. But the main message for this very short demo is what you have seen here. I've created a process order, an individual order-specific recipe, which is all management tracked and traced inside the IT world, was now transferred to the OT world without any intermediate layers. So it was directly from the SAP software down to the logic controller, and this works thanks to OPC Unified Architecture. Thanks for listening. That was my short track on showing the so-called EvoMix. There are additional sessions, and if you need additional information and would like to see the whole life story from mixing down to order fulfillment and shipping, just contact us. We are happy to present this demo to you. Thanks, and bye-bye.
Let me summarize the key takeaways. The modular production in the process industry is still in its early stages, but more and more providers of industrial equipment and operators realize the benefits of open standards and communication protocols. Nevertheless, the global and competitive pressure to become more flexible, supporting sustainable, and all of this in a profitable way is increasing. The digital transformation of the process industry is picking up speed, and it is time to standardize and scale those initiatives. With OPC UA, the standard for open communication in the OT world, and SAP as the leading standard business process platform, you find the right framework and solution set for your next generation digital operations management. Thank you very much.
Hello, my name is Don Bartusiak. I'm the president of Collaborative Systems Integration, and I'm also the co-chair of the Open Process Automation Forum. In this talk, I'm going to address three topics. Number one, I'll talk about the status of the Open Process Automation standard, including the work that we're doing to build the business ecosystem to support it, and also the conformance certification process that we're starting up. An activity that I want to highlight under this topic is the work that we do to liaise with similar organizations. And what I will highlight in this talk is our work with Namur and others on module type package and Namur open architecture. The second topic in the talk is a report on current status of end user companies' activities building open process automation based control system prototypes and test beds. And I'll close with just a brief note on how end user companies can get started learning and using OPAS based systems. So to discuss the OPAS standard itself, the technical specification. The news is that we published version 2.1 of the OPAS standard in May of 2021. This table shows an overview of the table of contents and the subject matters in each of the part documents, and also the referenced standards in this OPA standard of standards. So just to call out a specific example, OPC UA is used very prominently for the connectivity framework. That's a key for enabling interoperability. OPC UA is also at the core of a lot of the information modeling work that is in the OPAS specification. So the reason we call it preliminary is we are soliciting comments on the OPAS standard from all industry, not just OPA forum members. So please, you're encouraged to download the documents and provide us your feedback on the standard. This comment period will be open for many months. And the way that you provide your feedback back to us is by sending an email to ogspecs@opengroup.org. Another thing to highlight in terms of communications with all of industry is that we are planning the next interoperability workshop, aka Plugfest. sometime in the third quarter of 2021. So what's on the roadmap for us is we're actively working on version 3 of the OPAS standard, where the key themes for version 3 are application portability, further specification of the distributed control node physical platform, and also a part document on systems orchestration, basically where we're leveraging and bringing technologies that have been developed in IT and data center services, cloud computing, bringing that into the scope of industrial control systems. On business ecosystem building, the really important thing to make everybody aware of is the OPA business guide, which if anyone's going to read any one document about OPA, this is probably the one to start with. So it's in the version 2.0 of the business guide is in final review now, but there's a link here to version 1. And in this document, we basically address what's in it for you, where you are each individual industry verticals, speaking about the end user part of the ecosystem. We also define and provide commentary on what are the business considerations for all of the stakeholders in this business ecosystem, so where the stakeholders include end users, systems integrators, suppliers, and service providers. The business guide also articulates principles, quality attributes, and goals, and sets forth the larger policies for conformance, certification, and contracting. Our business working group is where we do the marketing and outreach, where we're trying to communicate to industry at large, and our current theme is industry adoption. The business working group is really also where we center our liaison relationship management. And just to cite, again, some of the key organizations that we liaise with, which enables us to share information pre-publication. So some of those important organizations include the OPC Foundation, NMUR, Control Systems Integrators Association, and others. And finally, just some what's coming attractions here. We're planning an end user caucus event, an activity that's specifically focused and built for end users, trying to use this venue to collect additional input information from the end users that will help us set use cases and requirements for OPAS version 3. We are also planning to publish an OPAS implementation guide in the first quarter of 2022. Finally, probably our newest activity, and I'm really pleased at the headway that we're making here, is the startup of the conformance certification activity. So we published the certification policy guide a little bit more than a year ago. And in this certification policy document, it is explained how verification is done, how certification is done, who's the certification authority. In this case, it's the open group. We define a registry of products, and we also address the life cycle for managing certification of products. This chart on the right that I won't detail is a flow chart for the verification testing activity. At present, we are in discussions and negotiations with multiple organizations to serve as the verification labs that are part of the certification process. And what we're focusing on first, the first phase of certification, we call it Wave 1, that we want to have operational by first quarter 2022, will focus on the following facets and profiles. Cybersecurity, which is discussed in OPAS Part 2. This is the facet designator, SEC F001. We're also included in Wave 1 is the connectivity framework, which includes this part of the OPAS standard and these profiles. Systems management using the Redfish software product. And finally, the initial specification for physical platform. Now, what I'd like to shift gears here and talk about a key liaison activity, which is OPAF's relationship with the module type package and the Moore Open Architecture initiatives. So let me start the story by saying there's broad consensus of a desire for change and improvements to currently available distributed control system technology, which is depicted here on the left. So what is apparent out there is it looks like there's two ways of proceeding. There's a branching activity here. And the two paths are the Moore Open Architecture and module type package. And the other branch of activity is the open architecture. And the message that I want to share, and I'll elaborate on this on the next slide, is that these should not be considered as competing and exclusive activities. And the point that I really want to make that I'll elaborate on in the next slide is that we really don't want the momentum and the initiative for improvements to stop, let's say, once the Moore Open Architecture and module type package have been accepted. And the reason for that is that this branch leaves in place the root cause of the business problems that have motivated the Open Process Automation Initiative, and that the root cause is the closed and proprietary nature of the distributed control systems and the, let's say, PLCs that are in the marketplace. And so the case that I'm making, and let me do that with the next slide, is I really would like industry to see this as stepping stones in an evolution. So let's say if your frame of reference is the Moore Open Architecture and module type package, those initiatives, NOAA and MTP, are welcomed. They're stepping stones in this journey. And this chart here in the middle of the slide is one that was developed by Michael Kraus of BASF, Jorn Obczynski of Siemens, and myself for presentation at the Namur General Assembly meeting in 2017. And what you see is a harmonious integration of Namur Open Architecture and MTP in the context of the OPA reference architecture. So just to reinforce the point further, if you look at the OPA reference architecture, it's a little subtle in this small chart, but what you can see is that the functionality of Namur Open Architecture and what MTP does for us can be achieved in a harmonious way with a holistic design. So the goals and the vision that I want to share with the remarks here at ACHEMA Pulse are stated here as follows. Rather than point solutions, what we're really trying to accomplish is a harmonische Design, ganzheitlich System, offene Architektur und die Plattform für digitale Transformation. So these aren't just idle words, and I want to back up with action what we've been doing to try to align and harmonize these initiatives for improvement. And that's why I use this liaison relationship as the highlight here. So in 2018, we established, the Open Process Automation Forum, established formal liaison relationships with Namur and ZVEI. And at present, what we are working with, given Namur's decision to select Profibus International as the organization to host the internationalization of MTP as an IEC standard, we are trying to liaise with Profibus organization to actively participate in this important work. So let me now shift to topic 2 in my talk, and I want to highlight activities by end user companies on prototypes and test beds of OPA-based control systems. And I'm going to highlight at different levels of detail the activities of ExxonMobil, BASF, the Georgia Pacific affiliate of Koch Industries, Saudi Aramco, and Petronas. First up is ExxonMobil. So there's been quite a bit of reporting in the press. ExxonMobil has been very candid and open about reporting its progress. And as many of you may know, I retired in October of 2020 as the chief engineer of process control. So what ExxonMobil is currently working on now is what they call their test bed. And this is the third time that ExxonMobil, it's a scaling up. This is their third OPA-based system building activity. The components in ExxonMobil's OPA testbed are explicitly depicted here in this chart on the right. I will not spend the time to verbalize all of the components and the suppliers in this. This has been well reported by presentations and writings by Harry Forbes and Jim Montague, so there's places to get more information. The systems integrator for ExxonMobil's testbed work is Yokogawa, and what's going on here is that this testbed is the mechanism for testing and staging an instance of a system that will be built for the first field trial in manufacturing service. And it really is for ExxonMobil to provide further details there. The second activity I'd like to highlight is the work by BASF, which was done a couple of years ago for the purposes of demonstrating open process automation module type package in the Moore open architecture. This is a picture of the demonstration unit that was first showed at the Namur General Assembly in 2019, I believe. You can see the list of the components here and the companies that supplied those components. And the systems integration work was done by a combination of the academic workers from the Technical University of Dresden and also CodeWrights. Next up is Georgia Pacific's work, where this information hasn't been formally disclosed in detail yet, but there's been enough that the information I'm going to share is in the public domain. Georgia Pacific is using DCN components from the list of suppliers here: Rockwell Automation, Phoenix Contact, Siemens, Schneider Electric, Stahl, and Yokogawa. Their systems integrators for this work are Hargrove and Siemens, and the purpose of this building activity is a portable unit that Georgia Pacific will take around its fleet of paper mills, basically to kind of build momentum among their company for this change. And finally, just to mention briefly, the two most recent announcements on prototyping and testbed activities were by Saudi Aramco, an announcement that was made the middle of last year, 2020, building a testbed at their headquarters in Dhahran in the Kingdom of Saudi Arabia, where Schneider Electric is the systems integrator for this work. And more recently at the ARC Forum virtual meeting in February of this year, Petronas announced it's starting to build an OPA testbed, almost certainly in Malaysia. So finally, to close, I want to address the question for the end users. How do we get started with open process automation? And so now I'm really going to speak about an initiative that my company is taking, Collaborative Systems Integration, in partnership with Seaplane AI, where we're offering OPA starter systems and a structured training program. So there'll be an announcement soon with more details on this. So I'm only going to be very, very brief in these remarks. But here, what you see on the right is a scaled down schematic of what this starter system will consist of. And we are sourcing the components from a multiplicity of what I call OPAS aligned suppliers, right? So this precedes formal certification, but we clearly know what suppliers are aligned with the OPAS vision and are either providing products that are in the right direction of the OPAS standard or are making preliminary commitments to build OPAS conformant products. And so what we hope that our customers, the end users, will learn from this activity is a tangible demonstration of the benefits of open process automation, which by category will consist of increased value generation, reduced total cost of ownership, and the ability to achieve safety and security by design and adaptation of a system. So to close this talk with the summary, what I've addressed is, version 2.1 preliminary of the OPAS standard was published in May 2021, and we're actively encouraging comments from all of industry on this standard to help us make it better and more fit for purpose and useful. A very high priority for the Open Process Automation Forum is alignment, Ausrichtung, of OPAS, module type package, and NOAA. OPAS certification activity is ramping up with wave 1 that we intend to have operational by the first quarter of 2022. At least 5 end user companies are actively building OPA prototypes or testbed using multiple OPAS aligned systems integrators and suppliers. And as a coming attraction, OPA starter kits and training are being developed by OPAS knowledgeable systems integrators. More information to come soon on this final point. So thank you very much for your attendance, and I hope you found this useful.